Welcome to the Explainer. You know, every single day we plug in our phones, our laptops, pretty much everything. But have you ever stopped to think about the magic that's happening inside that little power brick? Well, today we're going to crack one open, figuratively, to understand the brilliant engineering that powers our world.
Yeah, because it's not just a simple plug that's passing electricity straight from the wall to your phone. Oh no. This little box is an incredibly sophisticated piece of technology and is performing a complex and, frankly, an absolutely crucial task.
See, the power coming out of your wall socket, that's high voltage alternating current, or AC. It's great for sending power over long distances, but it would instantly fry the sensitive electronics in your devices. So this little box, it has to take that high voltage, step it way down, and turn it into a steady, low voltage, direct current, or DC. And it has to do all of this safely and super efficiently.
Now, the secret sauce to safety here is a principle called galvanic isolation. Basically, it uses a transformer to create an actual physical air gap between the high voltage stuff on the wall side and the low voltage stuff on your device's side. That gap is what stops you from getting a nasty shock if something goes wrong. And to make this happen, engineers usually rely on one of two superstar designs, the flyback converter and the forward converter.
So, let's kick things off with our first contender. This one is a huge favorite in the engineering world, mostly for its just beautiful simplicity and how cheap it is to make. Meet the flyback. Now, the slide here calls it an isolated buck-boost converter, which, yeah, that's a mouthful. A much better way to think about it is like a bucket brigade for energy. It doesn't just pass power through directly.
It works in this really cool two-step dance. First, a switch closes and the transformer just soaks up energy from the wall, storing it all up in its magnetic field. You can think of it like filling up a bucket. Then the switch opens and all that energy has to go somewhere, right? So it flies back out the other side, perfectly converted into the voltage your device needs. It's a store, then release system.
So, why is this design so popular? It all comes down to this. The transformer does two jobs at once. It provides that safety isolation, and it stores the energy. Because it's doing double duty, the whole design needs very few parts. And fewer parts means it's cheap and simple to build, which is absolutely perfect for the billions of chargers we all have lying around.
But what if you need more power? A lot more power? What if you're not just charging a phone, but you're running something really demanding, like a big telecom system? Well, that brings us to our second contender, the forward converter. Okay, this one's called an isolated buck converter, and its whole philosophy is the complete opposite of the flyback. It's not about storing and then releasing energy. No, this one is all about direct, continuous power transfer. In this design, the transformer has one job and one job only: safety isolation. When the switch is on, it just passes energy straight through, like a perfect translator. The job of storing and smoothing that energy into a perfect, stable DC voltage, that's handled by a completely separate dedicated component on the other side called an inductor. So you're probably thinking, okay, more parts, that's more complex, more expensive, and you're right, it is. But, and this is a big but, the trade-off is massive. By giving each component a specialized job, you put way less stress on everything. That makes the whole system much more efficient and way more reliable for high-power stuff. Think servers or cell towers, things that need hundreds of watts. Okay, time for the main event. Let's put these two head-to-head. Let's really dig into where each one shines, and more importantly, why an engineer would pick one over the other.
And here it is, the whole trade-off in a nutshell. The flyback is the scrappy, simple, cheap option, but its components are under a ton of stress, so it's best for low-power jobs. The forward? It's more complex, a little pricier, but its low-stress, direct transfer approach makes it the absolute champion for high-power, high-performance systems. It's a classic engineering dilemma.
But you know, that all sounds pretty neat and tidy, right? Well, this is where we get into the real-world messiness, because ideal, perfect components, they just don't exist. And that creates some really fascinating challenges for engineers. So what happens when you need to power a device that needs multiple different voltages, like, say, 5 volts for the logic circuits and 12 volts for a motor, all from the same power supply? The easy answer seems to be, hey, just add another coil of wire to the transformer. And you can do that. But there's a sneaky little problem that comes with it.
And that problem has a name: leakage inductance. It basically means that in the real world, transformers aren't perfect. Not all of that magnetic energy from the input side gets perfectly linked or coupled to all the output sides. A tiny little bit always leaks away. And this tiny imperfection has some pretty big consequences.
Which brings us to this great quote from MIT professor David Perrault. Because of leakage inductance, you get this problem called cross-regulation. It means if the power demand on your 5-volt output suddenly spikes, the voltage on your 12-volt output is actually going to sag a little bit. You can only perfectly control one output. The others are kind of just along for the ride. And as an engineer, you tend not to like that.
So after all that, the simplicity, the power, the messy real-world problems, which one of these designs actually wins? Who comes out on top?
And the answer is, well, there is no single winner. It's all about picking the right tool for the right job. For your phone charger, where every single penny counts, the cheap and simple flyback is the undisputed king. But for that powerful server that has to run 24/7, the efficient and robust forward is absolutely the way to go. It all comes down to balancing those trade-offs: cost, size, and performance.
And really, this is the constant puzzle of power electronics. Every single gadget you own has a tiny, brilliant solution to this exact problem tucked away inside it. As our world demands more and more power for everything from our cars to our data centers, understanding this fundamental balancing act is the key to appreciating the invisible, yet absolutely essential technology that powers our modern lives.